Okay, so it's 2 minutes after. I think it's good to start. Again, as said, we have the ability to start with some introduction. The presentation will start in a few minutes. Welcome to this second special session on standards organization organized by the Metaverse Standards Forum. I'm Thomas Stockhammer, and together with Leonard Deli and Christine, we are all board members and have taken on the duty to organize these sessions. We would welcome you to this presentation today about avatar standards related to communication. So we separated a bit because we believe we will have more around avatar standards. It's a relevant topic in the industry related to the metaverse. And I just checked before the call, we have more than 120 registrations. We already have close to 50 participants, and probably people, at least on the West Coast, are still waking up and joining. Okay, so let me move forward. I will introduce the presenters in a minute. And there's some logistics here that I would like to just mention. It's appreciated if you mute yourself when you're presenting. You can also add your company, your name. That helps a bit of understanding who is present. Meeting is open for everyone. We want to share this information to public. The forum is not an SDO and in compliance with antitrust and competition laws. So no detailed specification designs, patents, pricing, or litigation. We will publish what you find here on our Metaverse Standards Forum YouTube channel, and the slide will be made available together with a video recording. We always ask you to keep the discussion friendly, civil, and professional. There's a form code of conduct. And we will collect questions. My suggestion is that during the presentation, we keep the flow, but we collect questions and then we discuss these questions afterwards. There's two ways. There's a Zoom chat, which will be available during the meeting, and a Q&A to collect questions. We also have a Discord channel, which we just set up for the special sessions. And maybe some of my colleagues can put the link in there. And there's also a QR code there. So please feel free also to dump questions there. This will be persistent and allows also to have discussions after this session is closed. When we get to the Q&A, please raise your hand, and I will put you into the queue to check for questions. Good. Today's agenda, there's a quick intro to the Metaverse Standards Forum. This is our advertisement pitch. Then we have presentations by Imed Bouazizi and Hideaki Eguchi. They both work in standards related to avatar communications. This will be followed by a QA. Maybe a bit of a discussion relevance for the MSF, and we also have a survey afterwards for you to just get feedback on the format and the content of this session. Okay, so here are a few slides on the Metaverse Standards Forum, I'm not going to go through all of those. You can look through those, but what we want is we believe that interoperability will drive Metaverse evolution. The Metaverse combines connectivity of the web with immersiveness of spatial computing. And there's technologies and vectors that speak into this. They are mentioned here. All of this comes together in the Metaverse context. So we are interested on different technologies, and obviously also look in how we can support the technology development through interoperability. So interoperability is the foundational to the metaverse, and we believe the metaverse should be for everyone. That means openness is an important topic, and openness is given by standards. We not do the standards ourselves. We believe we can benefit of coordinating organizations. So the metaverse require constellation of interoperability standards, recommendation guidelines across different SDOs, where specialists will address specific topics. And a unique, neutral, and welcoming venue for this pragmatic cooperation between standards community and industry, not another standards association. That's what we believe this Metaverse Standards Forum can be. And for those who are members, we are very glad to have you on board. For those who are not members, consider joining, because I believe you're doing a great benefit for the industry to support this organization. So it's a bit more. We basically work in the topics that we work on the pre-standardization, so identifying gaps, what is in standards, and then we also create consensus here. We develop requirements, we analyze what is missing. Then we would hand over these requirements gaps to SDOs. that then in the special area would develop the relevant specification. And then in a post-standardization phase, we would pick up what was done and create support for interoperability, test beds, conversation, tooling, educational material, right? So it's a bottom-up approach. It's not that we have a very strict organization. We also look that we can support short-term business opportunities and so on. There's the forum is split up into several, or by now quite many different domain groups. We also have clusters those a bit, and those, without going into the details, we split this into working groups, exploratory groups, and proposals. The working groups are well established. They have a very detailed charter. They have chairs that have been elected, and they work on deliverables. Some of them are already in place since the incorporation of the forum. Others are new or under discussions. And just from a clustering point of view, an important topic is 3D interoperability, where, for example, the topic today will be relevant, the avatars. We have also engagement and education, digital twins, navigation and discovery. There's a technology stack that looks into different technology options from network requirements, device interoperability, 3D web interoperability. There's topics related to legal, to ownership, to identity, to ethical principles. I'm very grateful that we have many folks also look in this. And then we have use case verticals. Very prominently, the industrial metaverse is driving a lot of activities, but we also have new topics. So you find an overview there, slides will be shared. We invite you to get involved. That would help you to leverage this unique opportunity for leadership in driving meaningful interoperability cooperation to help create the next evolution of the internet. And what we basically have is we have an effective standardization engagement. We are a very results driven. And this is also, we have a global networking. So you would see that we have members from all around the world. And today we have an exemplary of this with colleagues from Japan, colleagues from the US joining, but also many from Europe. Final point is we have this forum SDO special sessions. We started this last year in order to invite organizations from outside to give us an overview of ongoing or completed standardization work. We clustered this a bit. We have a submission. So if you have ideas around the area, please submit it. The link will be shared. So this is a Google Forms. We will then evaluate this and invite for sessions in order to cluster topics. So if you have ideas about this, please use the opportunity to provide us information. This is enough about the advertisement pitch from the Metaverse Standards Forum. We hope you learned a bit. Let's dive into today's agenda. And as I said, we have two presentations. The first one is going to be my actual colleague, Imed Bouazizi. He will talk about enabling avatars in AR communication. A quick intro to Imed. He's working Qualcomm on different topics related to multimedia. And he's a long-term, well-known capacity in this area. In standards and research, and particular focusing recently on XR technologies, working towards AR communication, avatar formats. One of the topics he's deeply involved. And I don't going to read the abstract that was the pitch for you, but I would hand over to Imed for kick off the presentation and stop sharing. Imed, are you ready to go?
Okay, it should be visible now, I hope.
Yes, perfect. Go ahead.
Okay, thanks, Thomas, for the introduction, and thank you, everyone, for attending. Good morning or good evening. Yeah, so the topic of this talk will be on enabling avatars in AR communications. So I'll get a bit to some of the background, like why do we need standards in the first place? But the focus is really on the activity in 3GPP and which actually triggered some more activity in MPEG and how the collaboration between the two SDOs is working on this topic. So I think it's very obvious that interoperability is a key aspect here. So what we see today is a lot of fragmentation, lots of proprietary formats for avatars, both for like creation, storage, but also like for the distribution, animation, and so on. And that's obviously a problem if you try to develop a standardized service like what 3GPP usually does. Then that becomes an issue, and the need for a standardized format for avatars becomes like evident. I think side benefits would be that if you know the interoperable format, you can like do lots of things like even hardware optimization, stuff like that. You can also encourage like app developers to use or to build on top of that format, like by having like common APIs, common SDKs, and so on. So it's really, I mean, important to have like some level of interoperability, especially when it comes to like communication services and usage of avatar and these services. So let's step back and look at how 3GPP came to this. So 3GPP, maybe you know it from the like 5G, 4G, 5G, and 6G like aspects, but they also develop like services like your phone dialer that you use pretty much every day. So that's a service called multimedia telephony service developed by 3GPP. And of course, mostly people use it for voice, but it has other capabilities like video telephony, and even more recently, like with data communication over data channels, so something similar to WebRTC, actually, data channels. So you can like download web apps and run them in your phone dialer. While these might like differ from operator to operator, but they are being deployed in different places around the globe. And the way 3GPP works is it starts by trying to collect requirements, mostly like driven by operators that like make or formulate these requirements. Then it goes to a next level, which is the architecture, and people like develop or evolve the architecture there to support these new requirements. And then it goes to stage 3, where the actual like formats, protocols, and signaling and all that stuff gets standardized. And that's what is used to pretty much like implement the new features. So back in, I think, like a couple of years, 2021, I think, so the group formulated like requirements for AR telephony, so augmented reality telephony. So these are enhancements to the regular like multimedia telephony service, which would allow people like to communicate in a more immersive way. And it's not really limited to like smartphones. So we anticipate connected devices like HMDs or smart glasses to be a reality in the near future, hopefully. So one of the aspects there was the avatar communication. So there were requirements on avatar communication features as part of that multimedia telephony service evolution. So the use case is quite simple. So people like can wearing their glasses or HMDs, they can like start a regular call and then upgrade to an immersive call. So you would have like some network architecture offered by the operator, which like does all the heavy lifting of like the signaling, establishing the calls, and even like offers multimedia processing capabilities through like media functions in the network. So the way this would be realized in an avatar call scenario would be that once the call is upgraded, there will be like a joint session or a common like scene description that is shared among all participants. It could be like a meeting room or a living room or like even outdoors or something, some scene that maybe the server picks or like one of the participants would pick that joint scene. And then participants can start offering their avatars or like adding to that scene graph. Like they can contribute their content, which could be like, I don't know, 2D, 3D content, like slides or whatever, but they can also like offer their avatars there. And they get like fused in this common scene by the central server. And that's how it's anticipated to work. So looking at that, so requirements were formulated. It started with the architecture. So the architecture, IMS architecture, is extremely complex, but the changes that were made were simple. So like an avatar storage functionality has been added, so people can upload their own avatars. It gets stored there. Once they are in a call and they want to like participate using their avatars, so the other participants get invited to download that user's avatar. So we call it base avatar. And that's an animatable character, pretty much, that looks like the user. And then they only receive like animation streams to drive that avatar later on. So it starts with that initial download, and then the rest can be just the animation streams, which are used to do the animation reconstruction and then rendering of the other participants' avatars. One key aspect is really the developments we have witnessed in OpenXR with all the tracking extensions. I think the group has done a great job defining these in OpenXR. It's a bit unfortunate that not all of them are like endorsed extensions. Most of them are vendor extensions, but it's like a big enabler, I think, to start with these avatar communications. So OpenXR allows you like to track facial expressions, body pose, eye pose, hand pose, and so on, hand gestures and stuff like that. So it's very relevant for avatar animation. So, and the idea there was that if we can leverage these and use them to generate the animation streams and have like base avatars with these animatable characters, which are compatible with the OpenXR generated tracking information, so we can really drive these avatars in communication without a lot of without any penalty on the developer. So the developer wouldn't really have to bother on how to generate these animation streams. They can like extract them directly through the OpenXR APIs. As said, so there's support for lots of tracking functionalities there. So it's until like Kronos and OpenXR group like figures a way to unify these extensions. I think the system or this communication system has to be flexible enough to like accommodate different types of extensions, for instance, different blend shape sets, different skeletons and stuff like that. So there is a lot of signaling that has to happen to ensure interoperability, even though the formats are the same, but matching the animation streams that are generated by the sender to the what can be animated on the receiver, I think is a big challenge there, and that's where the glue work has to happen. Pretty much, that's the activity in MPEG and 3GPP. So if you look at it as an end-to-end pipeline, so we'd have like the glasses or HMD, which are like doing all that tracking and exposing it through OpenXR API. The sender will get access to these on periodic basis, for instance, or something like that, and then encode them in hopefully in a quite optimal way, efficient way. since a lot of the data we witnessed that a lot of the data is like irrelevant. Like if the user is smiling, maybe not all blend shapes are activated. You still get all of them through OpenXR API. So there is room for compression there, and that's something that MPEG is working on. And then these streams get sent to the receiver. The receiver downloaded already, like at the start of the call, the base avatar of the other party, and then can use it to do the animation. In some cases, there is need for like mapping or conversion between the two. Say you're using because the user changed their headsets. Now they have access to a different extension for face tracking with a different blend shape set. So that can get like converted to like to match what is already like prepared or stored in the base avatar, like the different blend shapes in the base avatar. So there is support for that to do on the fly like mapping or conversion between the animation streams and what is supported by the base avatar. So that's in short how it should work. And of course, it's bidirectional, or if there are multiple participants, this has to be done for every participant in the call. The good thing is that these animation streams, if compressed properly, they are very low bitrate. They can result in very low bitrate, eventually less than even like a 2D video, and definitely much lower than if you would like send a 3D dynamic mesh, for instance. So the MPEG has said to define like a format for that base avatar. So again, that stores like all the pieces or assets associated with the user's avatar in a way that makes it like animatable, but also like to facilitate like discovery of what is supported and what is not. Like, does this animation format work with this base avatar, things like that. So it has like it's a container actually that has like the different pieces of the avatar. You can also store like digital assets associated with that avatar, like garments or glasses or whatever the user has decided or has purchased or as part of their avatar. And during a call, of course, they get to choose what they want to wear or how they want to look like during that particular communication session. So all of that is facilitated by like an index file, which is that avatar representation format document, ARF document, which contains like a description of all the components and the sets that are stored in the container. And also describes like what animation streams can be supported. There is also support for like proprietary animation. So if you want to run your own proprietary animation, maybe through some machine learning algorithm or something like that, that people have different uses, like for this animation, for instance, they can like convert this into a Gaussian splat or whatever, and then render. So they can like store these proprietary or customized like animation modules, even or as part of that container. So that's the whole idea, that this would be a format that facilitates like exchange. Like you should, for instance, be able to capture your avatar once, use it as a storage for all your digital assets, and eventually like convert it into different formats. So it would be like an exchange format, but also an interoperable format. Like you can deploy it in whenever you need interoperability. So that's the need that was that MPEG and 3GPP are trying to address. If you look at the pipeline on the receiver side, so again, it retrieves these animation streams, and then it can run this animation function on the receiver side, and just then generate in a typical way, like in like a reference animation, you would generate a dynamic avatar or a dynamic mesh, pretty much, that represents the user. Of course, that's outside the scope of the standard, so you can like use the standard and generate something different if you want, but that's like the reference. The reference is really to reconstruct a dynamic mesh with its textures and all its components for every frame that you have to render. But again, as I said, proprietary animations are possible. So for the facial animation, it's quite simple. Based on the OpenXR, you can eventually use other frameworks like, I know, MediaPy from Google or like ARKit from Apple if you want. And with proper signaling, I think that should also work seamlessly. But that's the idea. Like, if you get into such a session, like in 3GPP, you would use like the data channel to send that. It could be in an over-the-top service, could be like a WebRTC connection. So you would stream these animation samples that you retrieve from OpenXR, and on the receiver side, you render. So of course, lots of standards would be involved here. Kronos, I think, has done great work, like developing essential like standards there for the rendering, like Vulkan or OpenGL and so on. OpenXR is definitely like a key piece of the thing, and then you can use it for tracking on the receiver side and for rendering on the for display on the receiver side for display, on the sender side for tracking. I think I won't get into the blend shape animation that much. I expect that since this is like a 20-year-old or plus 20 plus years old technology, like the FACS or FACS approach is very well known. So it's you have blend shapes and you just like create a weighted sum to determine the actual positions of the vertices. So that's how you generate different expressions. And that's actually what OpenXR tracks. Like OpenXR, if you has like each extension, or it has like a blend shape set, or it could even like have multiples. And if you know what blend shape set you're tracking, so you will get from the tracking, from the OpenXR tracking, a weight for each of these blend shapes, this WI weight. And then you just like do weighted sum to get the actual positions or displacement of the vertices of the face. The body animation is not very different, actually, except that instead of like blend shapes, it's tracking like the skeleton of the user's avatar. So each bone in the skeleton will get a position or a pose, so position and orientation, and that's what gets tracked by the OpenXR extensions. So you will get like positions for each of the bones, and then you can like use like LBS or linear blend skinning to determine where the vertices end up. And the vertex can be like affected or like influenced by multiple bones, actually. So the position of different bones may affect one vertex, but at least one, they should be bound to one bone at least. And that's how the animation works. That's actually all of that is stored, like the skeleton, the assets are stored in that container. It's quite flexible container, so it allows for like the assets to be, for instance, GLTF files that get combined together. A description of the skeleton is exposed in that document, And as I said, the description of the animation is also provided there. So the standard is like progressing quite well. So we expect it to be an ISO standard like by end of this year or beginning of next year, actually. Actually, it's getting into a stable phase sometime mid of this year with the DIS stage. If you're familiar with the ISO standards process, it's quite a lengthy process. But starting from CD, I think the technology is quite stable and can be used, or users can experiment with it. So the way MPEG works is it develops like reference software to validate like the standard, and if people are interested, they can get access to this. It's usually available for MPEG members, but it can be made available on request. So it's like allows like for animation of avatars, integration of avatars into 3D scenes and animation based on what was described earlier. There are, of course, next steps here. I think the most relevant one would be interactivity, which is a great topic. If you have multiple participants with their avatars in a shared space, how they can interact with each other. I think the work on interactivity, for instance, that the 3D formats group in Cronus has done is quite interesting there. So how the combination of both would work, I think, would be very valuable. But like also like developing tools in general to like leverage this exchange format, I think would be very relevant, like exporter tools, for instance, to Blender and so on. These are all planned activities that we hope will materialize throughout this year or maybe early next year to drive like adoption for this standard. I think that was it. I don't know, I'm doing with time. But I was told to leave some time for questions, so I hope that's fine. But before ending, so thank you again for attending. This information I think is repeated from the slides we saw at the introduction. Be more active, help us develop these standards, and let's see if there are questions.
Imed, thank you. My suggestion is that we go to the second presentation and then combine the questions. There's a couple of questions on the chat, so maybe we can start answering those meanwhile, and then we pick it up and discuss it a bit more. So I would like to move to the second presentation and then basically go into the Q&A afterwards. And the second presentation is again related to standards. So Hideaki Eguchi will talk about VRM. And so there's a bit more here. Hideaki has been a VR mobile app engineer in VirtualCast. And so he's also working as a translator, English to Japanese, has responsibilities on different topics in the VRM consortium, particularly public relation. He's also very active in the forum on our character and avatar working group. More details on LinkedIn. But Hideaki, it's your floor, so I stop here and would ask you to share your slides and present. And as said, please use the chat to discuss or Discord. That is much welcome. Hideaki.
So hello everyone. This is Hideaki Eguchi from the VRM Consortium. So thank you Thomas and Leonardo and Christine for organizing this event, and everyone attending this event. Thank you to all. So the title of my talk today is VRM, Practical Interoperable Avatar Standard for VR and Metaverse. So I'll first briefly explain what VRM is and go over the history of it, why it was created, with what goal in mind. After that, I'll touch upon the key features of VRM: bone structure, expression and tuning expression, eye movement and lip sync, tune shading, spring bone, first-person perspective, and license. Then I'll share how VRM is being accepted in Japan and how we're trying to bring it to the world as an international standard. Finally, I'll wrap up with key takeaways from this talk. So let's begin with the introduction to VRM. What is VRM? VRM, or Virtual Reality Model, is both a specification and a file format for avatars. A .vrm file contains all the data and information necessary to transfer a humanoid avatar across different applications. An app could be a Metaverse, a streaming app for VTubing, a social VR, a game, or a live show system for real-life music venues, or it could be anything else. You could think of it as a delivery format like JPEG, but for avatars. So basically, if you have a VRM avatar in your hand, you could travel across different metaverses that support VRM without much hassle. Now, I'd like to touch upon the history of VRM. Why was it created in the first place? So, in 2018, a company named VirtualCast Inc., which by the way is the company I work for, released a VR app called VirtualCast. VirtualCast is a VR VTubing app that allows you to turn into an avatar and communicate with audiences using chat, comments, and gifts. When we created this app, we wanted to allow users to import custom avatars they created in other apps. We wanted to make sure it was easy enough for users with no technical background, and we want to make the avatar loadable in runtime. And to cultivate this newfound culture of VTubing, we wanted to make the system open and interoperable. Before jumping straight into the creation of VRM, we did consider existing formats already in the space. The first candidate was FBX. FBX is the industry standard for authoring 3D content. It is excellent for handling over work-in-progress files across different applications. But it was too complex for just being used for an avatar. Also, it was a format not intended to be used in runtime. The second candidate was VRChat avatar format. It was already becoming popular back in 2018. Obviously, this format is made specifically for VRChat and only supports Unity as a game engine, which goes against our goal of creating an open and interoperable standard. The third candidate was MMD, or Miku Miku Dance, the popular tool for creating dance animation videos of Vocaloid characters like Hatsune Miku. The character model file for MMD, called PMX, was a common file exchanged among the MMD creators. However, the commercial usage of MMD was prohibited by its creator, and it was an ecosystem meant for video creation, not for VR. The final candidate was GLTF, a 3D scene description format that is created for the web and supports runtime loading. It is open and extendable. It can contain all the necessary assets in a single file, and the Unity library was available. So with all these existing formats in mind, we decided to create the VRM as an extension to GLTF. When we created VRM, we had these goals in mind. First, we wanted to make the VRM engineer-friendly. We kept the spec as simple as possible. Just enough feature sets to deliver an avatar for VR. We often hear that the spec is too simple. Creators want more features like custom shaders, programmable gimmicks, facial tracking support, and so on. While we understand the need for them, we are still keeping it simple for the sake of wide adoption. If the spec is overcomplicated, there will be fewer developers to actually implement VRM in their apps. Since we wanted VRM to be supported in as many apps as possible, we kept it simple so it was easier for devs to implement them. We wanted to make the VRM ecosystem open, which is favored among the dev communities. To avoid license chaos, we made a structured license based on the Creative Commons license that is embeddable in the VRM file. The second goal we had is that we wanted to design VRM for VR use. So we added first-person view settings, which I'll cover in detail later. Finally, our goal was to make the VRM a delivery format. We wanted to create JPEG of avatars, not PSD or Photoshop file. We are not creating an authoring format, which we think is the domain of FBX. So with these goals in mind, we developed VRM spec and VRM importer library for Unity and released a beta version of it in 2018. And to accelerate the interoperability of VRM, about 24 of companies, mainly in Japan, formed a General Incorporated Association VRM Consortium in 2019. And with refinements and refactoring, we released the version 1.0 of the VRM, the stable version, in 2022. Since we want to support VRM 1.0 in the long term, the features we release afterwards are released as optional extensions, which we will support in the Unity importer library we maintain. And that is a history of VRM. So that is a history, and now I'm going to go over the key features of VRM. Bone structure, expression and tuning expression, eye movement, lip sync, tone shading, spring bone, first-person perspective, and license. The first is bone structure. So before VRM, there isn't actually accepted standards that specified the exact bone name and hierarchy of bones of avatars before this. So actually some applications did, like Unity and Maya. So we followed the example of them, and we created the exact list of bone names and hierarchy for the avatars. So this is actually based on human IK, which is provided by Maya. So with this standardized bone names, applications can assume that specific bone has a specific name. So they don't have to do the guesswork, or users don't have to assign, like tell the application, like this bone is for right hand and this is for left foot, and so on. So with this structured hierarchy and name, all the avatar bones can be assigned automatically when importing to the app. So that is the bone structure. Then the next feature is expressions. So in VRM, you can specify 5 different expressions: happy, angry, sad, relaxed, and surprised. And expression can be a combination of morph or blend shapes, and color, and texture transform. So for morph, so I think Imed explained this in detail in the last presentation, so I'm not going to go over it in detail. But basically, morph is like you can define the set of vertices to be in different positions from the original position in the avatar and the 3D model. Then if you give a value of between 0 and 1, you can gradually move the vertices of each vertices to change its form into basically different expression. So that is morph, which is the illustration on the upper right-hand corner. And the color. So we wanted to be able to change the material color of the specific parts of avatars using this feature. So in the right bottom hand, so for example, your avatar may have orange cheek in its original state, but with the happy expression enabled, you might want to change its cheek to pink. So that is a color. And last is a texture transform. I think which is pretty unique to VRM. So what it basically does is, so you give texture to the avatars, and the texture is like mapped to the specific mesh of the avatar. And by shifting the assignment of the texture, you can change the expression of the avatar. Like in the original state, you just have two circles, and in the happy state, the texture shifts down, and now the smiley face, smiley eye portion of the texture will appear in the eye of the avatar. And there's also a feature for tuning expression, which is called is binary in the spec. So so normally expression can be controlled with gradual number between 0.0 to 1.0. This works for expression with morphing, but in the example of this texture transform, gradual change don't work here, because in the left illustration, you can see that if you gradually change the transform of the texture, your avatar will have an completely blank eye if the value of 0.5 is given to the happy value. So we created option is binary. So if you take this option for specific expression, then only the 0.0 and 1.0 of the expression is enabled for that avatar. So using this, you won't have a problem of avatar having a unwanted state of the state of the shape or the texture transform. So some of you may be wondering why only we have 5 expressions. Like in the last presentation by Imed, OpenXR have, I don't know, maybe 50 or to 60 facial expressions supported, right? So why only 5? So back in the 2018, so there was no de facto standard for the full facial expressions. So that is why we don't have it for now. And it is consideration for the future. But there is another reason for this, is that we kept it simple for the ease of implementation for developers. So this diagram explains the simple API that VRM Unity library we provide has. So basically, the app has to only tell the VRM to do the happy expression with the strength of, for say, 1.0. Then VRM internally comprehends that and see the settings that is set by the creators. So the creator may have set a specific blend shape to change to 0.8 and texture to move from 0.0 to 0, 0.5. Then they might also have assigned changing the color in like cheeks, for example. So basically, the app only have to tell happy 1.0. Then VRM does all the three expressions at once. So since we don't have VR headsets or AR headsets, that is, well, we do have it, but that is not common right now. It is easier for developers to just implement 5 standard expressions because they may not have those sensors. But still, your avatars act naturally and be expressive. So that is why we chose to have only 5 expressions. Next. So the next feature of VRM is eye gaze. So eye gaze can be done with bone rate rotation of the eye or the morph of the blend shape. And especially when you are using the bone rotation, you have to limit the amount of rotation that can be done for each eyes. Otherwise, your avatars may might look at somewhere like behind your head, and that is not what we want. So you can set a limitation for the eye rotation. And here again, we have the simple API for developers to use. Is that developer can just give the coordinates of the target that the avatar should look at. So in the illustration, in the light, if you just give the coordinate and tell the VRM to just look at this point, then considering the limitations provided by the avatar creator, the avatar will automatically look at the directions. So this is very easy for the developers to implement in their apps. And the next feature is a lip sync. So here again, we have 5 vowel shape that can be assigned to your avatars, which is A, I, U, E, O. And some of you may wonder, why only 5? So, since this VRM originated from Japan, since for Japanese language, basically 5 vowels is enough to express the most of the sounds in Japanese. So that is why we only have 5 right now. But since we are trying to make it international, there's a consideration to add more in future versions. And next key features, which is the important one for VRM, is the tune shading. We call it M-tune. So tune shading is very important in an avatar, especially in Japan, because most of the avatars created here resembles the style of anime. So basically, it's a stylized shading that is being used. To do that, we added these features to M-tune, or the tune shading material we added. So the first one is hard edge shadow. So if you watch animes, you will notice that the characters or the pictures generally have 1 or 2 like 2 steps of shadows drawn on them. But this is traditionally because for the reduction of the production cost, but now this is being accepted as a style of expression. So hard edge shadow. Then second, you can specify the shade of the color. So like in specific anime, you might want your shadow to look greenish or bluish. And so you can specify that regardless of the environments you are in. And you can also specify the rim color. So you can also, so like when you lit an object, the part that get the most light is basically the rim color. I mean, especially around the edges of the shape. So you can specify the color, specific color for that. And you can also assign matcap and UV animation. So UV animation means basically you can scroll a texture that is assigned to a mesh to do some unique effects. And there's also a parameter for outline, which is very important for the anime look. So these are the toon shading feature of VRM. The next feature is Springborn, which is a physics-based procedural animation. You can assign to hair, skirts, and accessories, and etc. So as you can see in the clip in the right, this avatar is using the Springborn for his tail with your connectors. So you can basically assign this to anything that moves along the avatar, which is pretty important especially for hairs and earrings and accessories and so on. And another feature is, and this is very specific to VR, and that is first-person perspective settings. So if you are using your avatar for VR or first-person like shooter, you have to put your camera on the avatar's eye or maybe between the eyes. So depending on the shape of the avatars, the best position for the camera may change. So we added a field where you can specify the coordinates that is relative to the head of the avatar. And we also added a feature that you can specify specific mesh to be hidden when you're using the first-person view. For example, you might want to hide your bangs or head of the avatars when you're using the first-person view. Otherwise, your hair may block the view of the user. You don't want that. So with this feature, you can specify the meshes to hide. And this is also a very important feature in VRM. So we embedded a predefined license with options for authors to choose from. So before VRM, so licensing for the avatars or characters was basically a chaos because every creators, there's a bunch of creators in Japan, first of all. But every different creator has different views on how their avatars should be used. Some may allow it to be used for commercial use, but some others only use it for hobby, only allows the use for hobby use. And others may only allow it to be used on specific like video streaming platforms. And others may allow it to be used on games, others may not. Others may allow the use of sexual use of the avatars, others may not. So there's a bunch of variations in licensing of the avatars. But that is going to be a problem in the metaverse settings because people are usually not aware of the license. Like people usually don't read the license when they purchase product, right? And so it was really a challenge to enforce this license to the users and app of the VRM. So to make it easy, we created this predefined set of license that the creator can choose to choose the options for each items in the license. So in the diagram below, so creator creates an avatar and releasing it in the avatar store. And when releasing it, the creator set the option for the violent usage, and they set it that the violent usage is not allowed. So that metadata is now embedded in that VRM file. Now, with that metadata embedded, the apps can filter specific avatars to be used in their apps. But of course, if they have to follow the VRM guideline, so the avatars with no violence allowed options ticked, they can be used in metaverses and VTubing apps and so on. But they cannot be used in aggressive games. And basically, the game will kick the avatars because the no violence allowed form field is ticked. So, so with this feature, users don't have to really worry about the licensing of the avatars because it will be filtered automatically for them. So this feature is very important in metaverse settings where general public will be using the avatar. So these are the key features of the VRM. And if you have questions, please ask me later in the Q&A session. So now I want to share the state of the VRM in Japan and how we are trying to make it international. So since its release in 2018, VRM is widely accepted as an interoperable avatar format in Japanese dev communities. This is mainly because the communities of VRM is mostly formed around Japanese developers. And we prioritized our communicating in Japanese and released lots of tutorials and documentations in Japanese. So that is partially why this is accepted in Japan. And in our showcase page, there is 176 app and tools that supports VRM right now. It might have been updated in last few months. And the over 2 million avatars is already uploaded to Vroid Hub, which is basically a cloud storage for VRM avatars, where you can link your app to Vroid Hub and basically import your VRM from that cloud storage Vroid Hub. And of course, there are a bunch of different platforms and cloud storage and different services that supports VRM. So there should be even more of the VRMs in this world at this moment.
Hideaki, can I ask you to wrap up a bit, because we wanted to get to the Q&A before we wrap up. Thank you so much.
I'll finish in a few minutes. So So it was accepted in Japan, and now we wanted to make it international. And to do that, first we joined this forum, MSF. Then, and we are already seeing some supports from communities outside of Japan. And with and last October, we also released a press release with the Kronos group that we will be integrating VRM functionality into GLTF to help increasing the reach and presence to international communities. So please look forward to that, and we are still working on it right now. So the takeaways here is VRM is an avatar spec and a format with interoperability in mind. And the ease of implementation is a priority for VRM. And it is made for Metaverse, especially for VR. And it is made for runtime use and not for editing purpose. And we embedded structured license for ease of use. And integrations with Kronos GLTF spec underway. So that is a takeaway from my presentation. And thank you for listening. And I'll send it back to Thomas. Thank you.
Hideaki, thank you so much. Great. So we have heard these two presentations now. So let me share just again, and we're really in the Q&A session now, and I saw there's already great discussion on the chat. Before we go and open up, let me share this one more time. So I invite you to also use the Discord to discuss after the meeting, so that would be great. But what I want to go is Q&A, and I wanted to check, Imed, you answered a couple of questions on the chat, so maybe you want to summarize what were the questions, what were the main answers to this. I think you provided also links to all of this.
Yeah, I think first of all, I think there is the link in the chat to access the specification, the MPEG-ARF specification. I think all 3GPP specifications should be freely accessible. If people are interested, I can point them out. We just recently finished a technical report on avatars and 3GPP, so if you're interested, we can share that too. I think most of the questions were about like let me remember. I think it's like about like can you store like customized avatars? Of course, I think that's the idea that these are customized avatars, so they represent the user, so they match their actual skeleton, their facial expressions, and so on. So we of course want to support like realistic avatars there. The format itself doesn't enforce a particular skeleton composition or a particular like blend shape set. So it's flexible. You can signal these. They get registered through URNs and they can be signaled. I think that's the main aspect. There was a very interesting question on like supporting like sign language and so on. I think that's a topic that needs to be studied more. Like, can you convert, for instance, like text to like facial expressions, for instance? I think that would be, of course, a very interesting use case and very useful use case, actually. So that there is some more work that needs to be done to understand what are the requirements of such applications, to see if ARF matches the needs or needs to be extended to support these use cases. Let me remember what else. Yeah.
That's fine. Let's just move forward and let's open up the floor for questions. Please raise your hand if you would have any, and we just pick it up. Any questions? I don't see
Well, I
any
have a
hands
question,
right now.
but the hand raising's not working.
Oh, hand raise is not working. Then just speak up. Go ahead.
Hi, my name is Chris. Thank you so much for this. I appreciate it. First of all, the Discord link doesn't seem to be working. I'd like to get a link to the Discord if you can place that in the chat. And the next question is for the avatar standards. Do you guys have any idea when we can think about having the avatars as a form of identity or an NFT as far as owning the avatar? And, you know, when you have emotes and different gestures, am I just a little too early to ask these types of questions? Or does this space need to like evolve a little bit before we get into the self-custody of an avatar, an interoperable avatar before? Do you guys understand my question?
Imed,
Yeah,
maybe you can a
extent.
bit from GP perspective with IMS and all. Maybe there's something around
Yeah,
there.
thanks, Chris. Yeah, I think it's of course a very valid question. I think the concerns on privacy, how to deal with deepfakes and stuff like that are very valid. We're just scratching the surface on these. Like on ARF, we have a few features in the standard that try to like protect users' identity. 3GPP has its own like security framework to ensure like you cannot offer an avatar if you don't really own it. That's of course being developed right now, so it's still not taking full shape. But there is this like concept of having a user identified or known to the mobile network operator, and that authentication relationship that establishes that trust, and that allows that user to offer their avatar. So I cannot, for instance, impersonate you or something like that. So yeah, I think that will turn out to be a very relevant problem and challenge. Actually, it's quite hard. Like some of the techniques in IRF would use like features from audio and the video streams to try and assert that this is actually the user that owns that avatar. So these and more, I think, being developed. So if you have any feedback, of course, any requirements, I think this is the right time to work on these.
Thank you
Thank
very
you,
much.
I believe I saw a hand from Neil, our esteemed president and also Kronos president. Neil.
I was just checking whether the hand raising was working. It was working.
Now you need to ask a question, otherwise.
Well, I guess I do have a question then. I mean, thank you to both presenters, both awesome presentations. I've learned a lot. Do you think there is to Ahmed's point that the ARF format can contain different actual avatar formats? Do you think there is an opportunity for VRM and the ARF to collaborate going forward? Is that something that both groups are thinking of?
From our side, certainly. I think we discussed this a bit in the avatar group in MSF, I think during one of the previous presentations, but I think that's definitely possible and also would be fruitful actually. At least developing like conversion tools between VRM, ARF would be very interesting. But I let Hideaki also share his perspective.
Yes, as for the VRM, our scope is specific to the avatars, and we don't really work on the like interaction and other parts like that. And so we are really open to other SDOs to incorporate VRM spec into their version of the spec. So yes, we are open and welcome to the collaboration in that regards.
Okay, thank you. Are there more questions? I believe we're getting a bit already into the discussion relevance for the MSF, but I would like to ask one question at least to Imed and also Hideaki. We see technical components being brought forward, right? So like formats, maybe also a bit of metadata coming along with this. At the end, I believe we want to have an interoperable service, and the service is not just the interoperability of the formats, it's also ensuring that we get an end-to-end service quality that is good enough. That means we need to make sure that capturing is correct, rendering is correct, that we also understand that we have maybe sufficient network bandwidth for all of this. So like a whole service, because probably a service that is not sufficient quality will break entirely the experience. So is there any efforts or work to basically ensuring a full end-to-end quality and service that we can do? Is there any work in standards, or how can this be addressed?
So as for the VRM, that is not in our scope of our work, but I think 3GPP is more like working towards that spot. So yeah, I'll let Imed speak for this.
Yeah, I'm sorry, Thomas. I don't think I got the question.
Now the question is whether we have. I mean, we're looking at service interoperability, like interoperability components, like animation formats and so on. But for a service, we really want to make sure that everything works, right? From the sensing, from the animation streams to the rendering. So is there more work happening to really ensure that we have an interoperable service with the quality we would expect? So not because probably a failing quality would completely, users would reject the service. We have also this uncanny valley we need to get past for avatars in particular for Umaid. So
Yes.
is there any work happening anywhere?
Yes, I think that's a very valid question. I think quality is very important. You mentioned that curve of acceptability of avatars. At least in these communication services, like relevant to 3GPP, the target is really having realistic looking avatars. So that's a big challenge, like getting past that curve, that valley actually. So I think that work would be very appreciated. That's something that the MSF can definitely contribute without necessarily like developing a standard, but help the understanding of what are the quality requirements, having evaluation tools or like metrics, or even like developing like rendering tools or things like that. I think anything that could help in that aspect, I think would be very valuable. On 3GPP side, at least there are plans to continue the work, try to understand and characterize such a service. I think that's, but any inputs from MSF or other groups, I think would be very valuable.
Thank you, Imed. Let me ask one more time. Do we have questions still anywhere?
Yes,
Kathy.
Friedland here. Hi. I have a small thing that I already mentioned in the chat. I think the opportunity for integrating accessibility in unprecedented ways, like, for example, integrating automated translation to sign language, is an opportunity that we really should look at here. Sign language has its own languages as well. So American Sign Language, British Sign Language, has also smaller forms like cued speech, with which you indicate that certain sounds are made in specific ways, easier to learn but spoken by fewer people. The big challenge in that field is when you have transitions between different gestures. then they are not just a sequence. So some of the movements you have to bring your hand down, and when the next gesture you have is up in your face, that's a long way, requiring also more time to look fluent, as if you already have a gesture that is close to your facial area and you're just transitioning between the two. So there is a bit of complexity in that, and I'm very happy to share the insights I have from working with a very gifted company on AI automated translation to sign language that maybe one day could unlock possibilities for us to directly speak in sign language with people with that demand that I personally wouldn't be capable of beyond that what my kids learn in their primary school. Yeah,
okay.
It's an opportunity.
That sounds
It's a cool opportunity.
Fridolin, maybe you just share on the chat any information you're having or put it into the Discord. I hope Discord is working for most of the people. So that would be excellent. Thank you.
Mm-hmm.
Yeah,
Sure.
I have one more hand from Ghazi.
Yes.
Okay, good. Go ahead.
Yeah. Thanks, Thomas. Thanks, Imed and Hideaki, for the presentations. Really nice. I have a question about this avatar communication in general. Imed mentioned that the focus is on realistic avatars, but I see that VRM at least seems to be very popular as a format in Japan, and the avatars were maybe not photorealistic. Do we see that such avatars could be useful over 3GPP networks? Thanks.
You're referring to cartoonish avatars?
Somewhat cartoonish or not photorealistic, yes.
Yeah. Okay, maybe a question for Imed, whether there is any effort into
Thanks,
keeping...
guys. I don't think it's exclusively limited to realistic avatars. That's definitely the goal. I think that's the coming from the requirements from SA1 and so on. The idea is that these are like users' avatars, but of course it's not really limited to that.
And
Okay.
as for the VRM, we also support PBR materials. So photorealistic avatars are not really popular in Japan, but it is possible with VRM.
Okay. So I have two more colleagues in the queue. There's Elliot. Elliot, go ahead.
Yeah, thank you. This is sort of along the same vein. I'm interested in the capability sharding or capability fragmentation that was mentioned on mobile platforms, performance-wise stuff. And if during requirements gathering for this interoperable avatar stuff, there was any sort of question or understanding or decisions made about like the necessity of an avatar on a local machine looking exactly the same or very similar or appearing and behaving to the avatar on like the remote machine, and if there was any discussion about sort of progressive enhancement stuff, or if it's like really important that these are the same objects, if you get where I'm coming from.
Okay, let me check if Imed or Hideaki can respond to that.
Maybe I can try to respond. Yeah, I think one of the requirements we had is really having support for maybe not necessarily progressive in the first state, but support for multiple levels of detail. So you could have like some form of adaptation, like if your receiver has poor network conditions or like restricted resources. So it can like operate and try to animate like a lower level of detail of the other participants. So
Right.
Progressive, I think, is definitely the next step. Like you could start with a low level of detail and progress to a higher fidelity, like representation of the avatar. I think that's definitely one of the like use cases we have, especially looking at like communication over wireless networks like 5G. Definitely, yeah.
Do you think it's down to the applications to sort of filter and change the level of detail, or
Yes.
so there wouldn't be any sort of support by the protocol to like request a lower level of detail animation stream?
Okay, so two things. So the format has to support this switching between the levels of detail. smoothly. And then the protocols that is outside of the format, like for instance, 3GPP will define protocols for this adaptation, but you can use the format without the 3GPP protocols. You can develop your own like negotiation and signaling and adaptation schemes for that. But definitely, I think 3GPP will develop its own for their very specific use case.
So that sorry if I'm taking up time. Last thing I promise. Like, so does that imply that the application requires knowledge of each specific format that it may get from a 3GPP sort of communication to be able to interact with those sort of LODs, progressive enhancement features at the format level? I suppose that's probably
Not
inevitable.
really, because that's like 3GPP is targeting your phone dialer on the phone. So basically, we know, okay, these need to comply with the standards, and the standard is the UPP standard. But if you're operating off the top, say using WebRTC and developing your own applications, I think there is no requirement or hard requirement to use 3GPP protocols. You can develop your own. I think the format's applicability is beyond the 3GPP use case. I think it can be used beyond that, coupled with your own protocols and so on. I think there is value in standardizing these two, but that's not what MPEG is set to. Maybe 3GPP will look beyond their multimedia telephony service after that and publish specifications for the signaling and negotiation and adaptation that are applicable to other use cases like WebRTC and so on. I don't know which SDO would be best to develop these and establish like some interoperability in that area, maybe IETF or I don't know. But yeah, I think the key point is that the format can be used without the 3GPP negotiation, but 3GPP will definitely address these use cases because they are very relevant for the 3GPP environment.
Yeah, what I'm observing, and I want to hand over to Neil for the last question, that I believe there is more follow-up. And we should check quickly even what the MSF could do in this domain. But Neil, go ahead, and then I want to wrap up and then just invite to the survey. But Neil. Or is the hands down? Maybe it is.
Yeah, a quick question. I know we're almost out of time. Quick question. I mean, and kind of relates to the role of the forum to bring different standards organizations together. Interesting conversation around the photorealism. I think the tune is really a good beachhead, but moving forward to photorealism, are there standards organizations out there that anyone knows that are doing good work on photorealistic avatars that we should reach out to and bring into this conversation?
I'm aware that basically there is a work to have mesh-based representations of avatars. That's more on the representation form. It's also on the compression of those, right? Because these are huge. So Imed, you might have a bit more because we look into this as well, right? So this is a topic.
Yeah. I think we looked into this. I think like proprietary formats are doing like huge advances in that space. But unfortunately, the standards world is not keeping up, or at least we couldn't really identify ongoing or like existing standards that address that use case. So probably proprietary formats will rule for a while, but there is definitely need for like interoperability and having like some standards there.
Yeah. Okay.
I hope MSF can play some good role there to drive that. Maybe even like trigger some of the standards work around that. But unfortunately, there is not much already. I think the MPEG, when that started, was maybe one of the very few.
Yeah. Okay. That makes sense.
Okay.
Yeah. Maybe a little early. Yeah. Thanks.
Excellent. So we had a bit over time, but I want to wrap up quickly. And I think we close the Q&A. Please use Discord or reach out to the presenters. I believe we should pick up that topic somewhere in the MSF. There is the Avatar Working Group. Hideaki, that would be one aspect to do this. We could also find other environments. I believe we have some further questions, right? And potentially even that we should write down the requirements that a service around avatar communication should fulfill, from identity management to representation to partial access to protocols to quality and so on and so on. And basically maybe do a listing against this, what exists, and maybe that would be a good, like a white paper or something that is presented to the outside. I would invite that we do this somewhere in the MSF. It would be just a question if we have a working group that can pick up that duty. Quickly, anyone would say, yeah, that would fit into this working group, or should we put it outside a working group?
Yes, for the Interoperable Avatar working group, the quality of service and so on is not in our scope. So I hope there's other working group that can work on that. And I'm not aware of that as of yet.
Okay, so I believe I bring this back. Let's discuss this on Discord and see what we can do, how we can integrate some of these questions. We also have ways to bootstrap such discussion. Please stay connected. As I think maybe Discord is a good way, but there's surely other means as well. And we will follow up on these topics in the MSF. Again, I ask you to participate in a session survey. So there's a link here. I also put it into the chat. Maybe one more time we can add it. And to wrapping up is all materials will be posted on the website, recording, also the slides. I also put already a link to the slides in the chat. Consider joining the forum. The forum will pick up some of these questions. And we hope that by picking up these questions, defining more from a requirements and gap analysis point of view, and also mapping the existing standards against these requirements and gaps that we have identified, we identify further gaps but serve the community with an end-to-end interoperability on this avatar. I think there's a great opportunity moving forward. Finally, there's future session proposals coming up. And if you want to participate or propose something, there's also a link. There's a QR code, but you will also see this as part of email communication coming into your mailbox in a couple of hours or latest days. Here's the forum contact, and I would like to close the meeting with this. Thank the speakers and all the participants, and wish you a great day. Meet you soon. Thank you so much.